Welcome to Forester University's Get Schooled in Gravelogy webinar. Our presenters today are Steve Jenkins and Ken Skorseth from Gravel Roads Academy. I'll be introducing today's speaker in just a minute, but as we wait for everybody to come online, I'll cover just a few housekeeping items. First, my name is Beth Tompkins. I'm the Director of Education and Training at Forester University. I'll be your moderator today behind the scenes, taking your questions for Steve and Ken throughout the broadcast so they may address them during our Q&A session at the end. Today's webinar is scheduled for approximately 1 hour with a 15 to 20 minute Q&A session to follow. Those who stay to the end are eligible for a completion certificate towards 0.1 CEUs and 1 PDH credits in states where applicable. These certificates will be emailed to those who qualify. Today's webinar is interactive and we encourage you to ask questions throughout the webinar. You may do so by entering a question in the question box here and clicking send. Those will come to me and I'll pass those on to our speakers today for our Q&A. If we don't get to your question for some reason, we'll be answering all remaining questions via email. You may also check your audio here. If you do not have audio or are having trouble, please enter a question in the question box and I'll try and help you as soon as I pass this on to our speakers. There are a few best practices we recommend for an enjoyable experience. First, I recommend jotting down this website here and this meeting ID. This will allow you to get back into the webinar if for some reason you need to jump out and back in again. Second, we recommend using a high-speed connection with all other windows and programs closed to avoid any audio or visual lag. Third, we recommend turning off or setting aside all cell phones to avoid any buzzing or static with the audio. Also, we are live tweeting this webinar. You can join the conversation on Twitter by following us at ForesterU and including hashtag Gravelogy in your tweets. We'll be following your comments and questions there during the webinar as well as after. And with that, I'd like to introduce our speakers today. Our first speaker, Steve Jenkins, brings 25 years of experience teaching gravel roads coursework to Forester University. Jenkins received his master's degree in geotechnical engineering at Utah State University in 1985. As an employee at the Utah Department of Transportation, Jenkins worked in roadway design, transportation planning, materials, research, and hydraulics. For the past 25 years, Jenkins has taught gravel roads coursework in 10 western states and has been involved with local and tribal governments. Jenkins also participated in 2 research projects on gravel road stabilization and wrote and edited the Montana Association of Country Road Supervisors Motor Grader Operators Handbook and Gravel Roads Part 2. Back to Basics, which provide the necessary text for lead author Ken Skorseth and the Federal Highways Administration to publish gravel roads design and maintenance, which is now used in gravel road courses across the United States. Our second speaker today is Ken Skorseth. Ken has spent over 40 years studying unpaved roads all throughout the United States and as far away as New Zealand. Skorseth's experience includes work in the highway and heavy construction industries, management of a county highway department, and for the last 22 years as a field service manager, program manager of the South Dakota Local Transportation Assistance Program at South Dakota State University. For 20 years, he has been educating engineers, managers, elected officials, and maintenance workers on subjects such as gravel road maintenance, low-volume road maintenance and management. He has also served as the lead author of the Federal Highways Administration Gravel Roads Manual. In 2011, Ken's contributions to the industry earned him an introduction into the South Dakota Department of Transportation's Hall of Honor for his lifetime contributions to local transportation in South Dakota and the nation. And with that, I'm going to go ahead. We're going to put this on our agenda for today. We're going to change this over, and Steve's going to take us through the first part of our presentation, followed by Ken for the second part.
Very good. Steve Jenkins here, and I'm honored to be with you today and glad to see so many interested in improving their gravel roads in the agency they serve. Hopefully all of you gain a little bit of information today, take some things back with you can use. If you are an experienced motor grader operator, we thank you for your service, and we hope that there are a few things you can take with you today to learn to improve your roads. What we hope to cover today is design and maintenance of gravel roads, starting with the shape, how important drainage is, the blading techniques, the importance of good base material, and also surface material. Ken will cover some of that, and we'll go on to cover stabilization, all the preparation that's needed, the importance of good material, and the importance of shape. I want to look at the roads that we were handed. Many of them weren't designed. They were made early on in the history of our country as access roads to retrieve minerals and later as farm-to-market roads. Engineering attempts to survey those roads put those on section lines, which gave us roads that had a lot of 90-degree corners, a lot of maintenance problems. And so we're kind of given the roads that we have. We want to talk about good design and good maintenance. Really, our roads, a lot of them have not been designed. They've been handed to us, and then they've evolved with every stroke of the motor grader, with every bit of materials that we've added. They've been improved. Ideally, we'd like to take those roads and flip them upside down, build a good base of free draining material, and have good surface material that acts as close as we can get it to act like a paved surface. But that's not the way we're given roads. So when we talk about design, it's somewhat idealistic of what we'd like to have. In the state where I live, 76%, or nearly 54,000 miles of our roads are unpaved. It is the lion's share of the roads. Many of those, most of them, are maintained by counties. Some are maintained by the Forest Service and BLM. If we look at the ideal shape of a road, you can look at those 5 and probably pick out each one of those shapes somewhere in your agency. Flat roads are very typical. Through improper maintenance methods, we get a parabolic crown. And I've been asked many times what's wrong with that type of a shape. And if you observe that, it's relatively flat across the middle third of the road. The outside 2/3 are too steep. Our preference is to have that A-shaped crown where there's a uniform slope from centerline out to the shoulders. Then there would be a hinge point that continues onto the ditch. As I travel roads in the southwest, Nevada, Arizona, and New Mexico, I see a lot that are U-shaped, where the agency will just scrape down to the next hardest level, and push material off to the side. And then the center of the road becomes a drainage path. And then the shape on the lower left, that superelevation may be used effectively in curves, but isn't the shape that we would want on the majority of our roads. So we've already decided on the A-shaped crown. The ideal slope that most research comes up with is a 1/2 inch to 3/4 inch per foot. For today's purposes, I'm going to stay with a 1/2 inch per foot. That way the crown is not excessive, it's achievable, and it is comfortable for drivers to maintain their position on the roadway. If we think about a 24-foot road, 2 12-foot lanes, from center line to edge line at a 1/2 inch per foot, there would be 6 inches of fall from center line out to our shoulder. And ideally, again, it would be a continuous uniform slope. Those that try and achieve this find that they'll undercut the shoulder a little bit and leave this berm on the shoulder. That comes from lack of good material, and when we don't continue that slope all the way out to the ditch line or daylight the slope. And we really defeat what we're trying to do Effectively, we're trying to get the water to run off of the roadway into the ditch and then be carried away so that it doesn't seep down into our road base. And you can see in this picture that the roadway has become the drainage path. A lot of effort is required to minimize or eliminate those shoulder berms, but it's very well worth the effort. I like to call these two slides an example of road reading, where we can observe common problems or defects on our gravel roads and then realize what's been happening and realize how to change or improve that. The old adage says that if we don't know what caused a pothole we fixed today, we'll be fixing it again tomorrow. And so we look at what caused these defects. The picture on the left is a curve or a turn on a gravel road where we have not handled our drainage properly. Drivers are always going to drive on the inside of curves and try and maintain their velocity coming in and out of a curve. And if it forms a low spot as they push material to the outside of the curve, that will become our drainage. As the material softens, you'll notice that the water that splashes out of that hole is a brown muddy color, which means that the water is taking material with it and the hole is getting deeper. We can fix that by bringing material in from the outside of the curve and fixing the drainage, allowing water that does get there to move away. The next picture on the right shows a lot of potholing and surface disruption on the lower right side of that picture near the paved road. If we think about blading operations, almost always you'll cut with traffic. You should do that. But if you start in that same position every time, it's going to be a good 50 feet before material starts to roll off of your moldboard to the center of the road. And so if you cut in that same place every time, you'll notice that a low spot develops there. Solution? Either add material to that area or retrieve material that you've moved and bring it back into that area. We need to talk about drivers' behavior or their habits. Anybody that's driven a gravel road will notice right off that drivers tend to crowd the center. Things that push them to the center are inconsistent crowns, inconsistent roadways or edges, parked cars, obstructions. When we don't keep the center of the road the center of the road, the driver's always going to want to either straddle the center or drive in three-wheel tracks. This is a very good picture of how the center of our road, which receives twice as many loads, wears out quicker. So the more consistent we are with maintenance, the better off we're going to be. Now I want to ask a quick poll in terms of who we have in the audience. Which of the following best represents your role? That of the laborer, a motor grader operator, a working foreman, a road supervisor, or other, possibly a decision maker or elected official. So again, the question is, which of the following best represents your role? A laborer, motor grader operator, working foreman, a road supervisor, or other, a decision maker or elected official. Please take a minute and answer this poll.
All right, well, good. Well, we've got a few last votes coming in right now, so just go ahead and click on the answer that you want to answer there. And I'll go ahead and pull up our results for us today. All right, well, it looks like we've got a large percentage of the audience today. 88% come in as other or decision maker. We have 2% as working foreman, 8% as road supervisors, and our last 2% motor grader or operator.
Okay, thanks, Beth. And I appreciate your response. Only 2% operators here. That kind of seems similar to what we have here in Gallatin Valley. This is where I live in Bozeman, Montana. And of the 50,000 people that live in our county, the only 12 that don't know how to run a motor grader are the 12 that we have hired to do that. Everybody else is an expert on motor grader operations. So hopefully the rest of you, the 98% that aren't motor grader operators, have those skills and can give us some good suggestions. If we look at drainage and just how important it is on gravel roads, the things we need to understand are drainage, drainage, and drainage. Really, the basics of drainage are to have good, clean, clear ditches, have our culverts cleaned out this time of year when their full capacity is needed, and then possibly the use of underdrains in some areas, or a geotextile. Now, that underdrain characteristic can be handled with simply using good free-draining material or open gravel, similar to what would be put under a paved road underneath of our unpaved roads. This time of year we see the drainage problems. If there are washboards on our roads, they get magnified or become larger. These are usually caused with the natural frequency of which a car suspension will vibrate. You'll notice these washboards are worse where people brake or accelerate aggressively. But once that water settles in the low spots and softens that material, they become larger very quickly. You'll notice in this picture that it's kind of an erodible material, which is a silt. And if those ditches aren't maintained properly and we don't have a culvert occasionally to offload that water to another side of the road or to a natural channel, then we get severe erosion on our road, and it does affect our road base. Culverts can be overrun if they are clogged with debris. And water can flow right over the top of our roadway and damage our road. So there's a real need to be able to pay attention to our ditches and culverts. Also, we need to look at the length of the culverts when we put them in. As you drive mountainous roads, if you notice these notches, or any gravel road, it's an indicator that our culvert was put in too short or not out where it needed to be. Now, granted, on a mountain road where people hug the inside of a curve, the road may have migrated to the left past the end of the culvert, and now you have that slight nick in the road. Either way, care should be taken to put in culverts that are long enough. You need to take into account the height of fill. If your side slopes are on a 3-to-1 and you're on 6 feet of fill, that would put 18 feet on either side of the road, additional length that you would add on to your 24-foot road width. So you'd have to put in a 24-foot pipe and then 36 feet more. So special care should be taken to put in pipes that are long enough. If you look at the distortions on this road, if they match the angle of the moldboard, then the operator is putting those defects in the road by operating too quickly, allowing that motor grader to bounce. Preparations for doing good maintenance. Always you should put your signs out. In some rural areas we do allow the driver to put out one sign, grade to the other end of the road, and then put a sign out on the other side. But they should be in place. Also, he should have a rotating beacon or strobe light on his grader and a slow-moving triangle on the back. You notice the water truck in the back. It's essential to have enough water to open that roadway up. Sufficient water does a number of things. It reduces wear on the moldboard, on the cutting edges. It makes it soft so that the roadway can be cut easier. The water prevents segregation or separation of materials as the motor grader operator tries to mix and blend that material to get a good mix. And it allows for good compaction. This is Joe Miller. He's our operator trainer here in Montana, does training with me, and you can see he's got a pretty full blade of material. He's going to be moving a lot of material today as I show you 3 or 4 passes. Now, this is not intended on showing you all of the passes that would be needed on say, a rehabilitation of a gravel road, this is where we reshape the road. It's not just smoothing and leveling. And so we really recommend that the gravel road be reshaped before we do any kind of treatment. And I'm just going to summarize those passes made today. You can see that the material has been pulled out of the ditch. It's up on the roadway, on the shoulder, and we're working that road to the center of the road. At 45 degrees, the width of that moldboard, if it's a 16-foot moldboard, is going to be about 9.9 feet. If they catch that windrow on the outside edge of that blade, they'll be able to move that clear across and pretty near the center of the roadway, maybe 2 feet shy of the center. You can see that's exactly what's going on here. Joe is moving that material good 9 feet in towards the center. You can see the center of the road in between the two windrows. The ditches have already been cleaned. He's just bringing the material in that he's retrieved from the ditch. And he's cutting to the bottom of the defects in that roadway. He's already started his compaction there. What he'll do is combine, I'm going to back up here, he'll combine those two windrows that are near the center and kick them over into a uniform windrow on, let's say, the right side of this picture. And then he'll perform a layout pass, working the material both ways across that lane. And then his last pass will be to take what material was left of that windrow, hopefully half of it, and spread it across the right lane there of that picture. And he is compacting at the same time. You can see what kind of a uniform, clean surface he gets. You can also see after the picture was, or the process was complete, that he has a slope of 4%, which equates to a ½ inch per foot. I highly recommend these slope meters. It's very hard for an operator to get the slope desired without them. Now, just to pick out a few maintenance headaches, one I talked about earlier is here on curves or turns. On a turn this sharp, you can see drainage collects on the inside edge. Solution would be to work material into that area and provide for drainage. Also, you can't do what, say, Powder River County did here, and that is pour a big concrete post in the middle. The road supervisor told me after he installed this the first week, there was a little pile of rear view mirrors collected inside of the curve. Obviously not allowed on our roadways, but as Ken recommended earlier, and he may talk to you about it, simply putting a delineator inside of that curve will keep people out of the roadway. Another solution is to look at why we get rough corners. If you look at the way we grade a road coming into a curve, we go from a full crown of 4% to a transition stage and then into a superelevation. That superelevation is going to match the crown that we'd like, a ½ inch per foot. Trouble is we have in the transition a flat area coming into the curve and out of the curve. And that coincides with where people will either brake or accelerate aggressively, and it's exactly where we get our washboards before and after a curve. I'll back up and just recommend that we minimize that flat area in our curves. I know some counties have maintained the crown all the way around the curve, and in some areas of the country that's not allowable. That super elevation has to be there. But in any regard, once we get that curve stabilized or set the way we want it, we should stabilize it with a chemical to avoid movement of material. As I travel around the West and teach, I always like to pull up a geologic map of the area where I'm teaching and even get into more detail in the specific county where I'm at. It shows you the type of material that's available. Most often our pits are alluvial pits where nature has collected gravel for us. One problem with that type of a pit is that the sizes of material have been separated due to the stream flow at that time of year. So you'll get bands of sand or gravel, or even up to cobble. As the river slows down, it loses its ability to carry large material, and that's dropped out in certain layers or as the season progresses. And so we get those banded pits where a loader operator has to blend that material. What we want on our roadways is a well-graded material, a little bit of each size mixed in. And on the surface, there should be specific interest in our silts and clays, the finer grain materials. The most common sources of material, quarry aggregates such as limestone, quartzite, granite, and even glacial deposits of stone, sand, and silt. And then we also get the river run gravel that's separated. And so we have to become familiar with that pit and know how we're going to blend the material to make it most useful for gravel roads. So then we need to blend in all of the different sizes. And when we purchase gravel, we need to make sure that we have a spec. So if we process it ourselves, we need to do good handling or good processing techniques. If we purchase gravel, we have to have a spec to be able to communicate with the supplier exactly what we need. We give to our counties a typical section. Feel it's very useful. This just summarizes that the base material can be larger rock, up to 6-inch material, and it's okay if it's a little more rounded. When we get to the surface material, the top 4, 6, or up to 8 inches, we want that to be 1-inch minus material. Ideally, it should be at least 50% fractured faces. I know in some of the DOT specs, they talk about 90 or 95% fractured on 3 faces. So to ask for 50% fracture is not too demanding on these suppliers. Our side slope should be 3-to-1 or 4-to-1 so that it's a recoverable side slope. If we look at the base down below our road, we assume that that base is either a low support subbase, medium, or high. Ideally, we'd like a high support subbase. That number there, CBR of greater than 10%, is a measure of how stiff the subgrade is. Between 3 and 10 on the CBR ratio would be medium support, and low would be less than 3. If we have low support, we're just going to need more base and more surface material. Now those two layers combined need to add up to our design thickness to help distribute the weight of the very large trucks and equipment, agricultural equipment on our roads today. Just a quick example of how to use this chart. First of all, we need to know what traffic is on that road. And really, as far as deep damage and rutting on our roadways, the only vehicle that's going to cause that problem is heavy trucks. Now, I agree, vehicles, pickup trucks, horse trailers, empty, they're going to cause surface disruption. But the deep damage is done by heavy trucks. So let's say we had 0 to 5. Let's say we had 5 trucks a day on our road, and we have very high support. That would require 14.5 inches of design gravel to distribute that weight. If we go all the way to the bottom, where we have as many as 50 heavy trucks and low subgrade support, that would require as much as 14.5 inches of combined base and surface material. And that's about as deep as I'm going to get into roadway design today. We need to be able to spot check our material on the road to see what's out there and see how we can blend that with other material. We should also have a set of sieves to be able to test the material that we're either producing or purchasing. And put them in the back of the truck, and if we never use them, it makes us look good by having them. But I feel they should be used daily. We do recommend a sieve test here. Let's see if I can somehow look at the last column. That's what I want to see right there. The size on the left of this chart shows the size of the gravel, and then the next 2 columns show the percent passing each sieve. I don't have time for a lengthy explanation of these sieve tests, but you can see over on the surface material on the far right, we would like 100% smaller than 1 inch, and we would like 80 to 90% passing the 3/4 inch sieve. So we allow that supplier range so that if they hit anywhere within that range, we're not going to reject their material. On the 1/2 inch sieve, we're between 60 and 80% of our material. And on the number 4 sieve, which is really close to 1/4 inch, 4 openings per inch, we allow 50 to 70%. Now, this is a Montana spec, and Ken has a little different one in the national manual, and he'll explain a few things on that. I look at the number 8 sieve, and we're between about 40 and 60. So right in the middle of that spec is 50%. Half of our material should be more coarse than a number 8 sieve, and 1/2 should be more fine. Any of the material that passes through the 40 sieve we call either a silt or a clay, and with that material we do a test called Atterberg limits to find out our plasticity index. So really anything that passes the 200 sieve is a silt or a clay. We do like to have a large percentage of material in that range. It's really the binder, the cement that holds our road together and allows it to act like a pavement. Plasticity index becomes very important as Ken talks about treating a road. We would like this to act a little bit plastic so that there's a range of moisture over which it acts plastic, and that's what that 4 and 12% denote, is that if you only have 4% moisture or 12, it will continue to act plastic and not act as blow dust. That's also a good indication of having enough moisture. You need to be in that range to be able to work the road and to stabilize. I know I'm going on about material. It is one of my favorite topics. It's also one of Ken's. This is an indication of the plasticity index. We come up with a liquid limit with the brass dish. That's simply the percent moisture when that material stops acting like a liquid, or when it flows together and fills that 1/2 inch gap. We'll drop that little dish 28 times and see if that gap closes. On the right, you make a 1/8 of an inch string, and if it crumbles, then you put it in the oven and measure the percent moisture. That would be the plastic limit. And the difference between the two, for example, if we had a liquid limit of 20% and a plastic limit of 10, our PI would be a number 10. Okay. Slides aren't advancing very quickly here. There we go. This is an example of a road that has too many fines, too much silt, and it's highly erodible and also ruts easily. This is an example of a material without the fines, and you can see very few fractured faces in that gravel. So the material then would move very easily and not have the binder to keep it in place. Now it's time for a quick poll. This is, are you a decision maker for gravel road maintenance? Yes or no? Again, are you a decision maker for gravel road maintenance? Please answer that question.
All right, good. Well, we've got the votes are coming in, so I'm going to give it a couple more seconds, then I'll close it down and we'll take a look at what the audience says today. And it looks like we have 68% say that no, they're not decision makers, and the other 32% answered yes.
Thank you, Beth. I would give you a strong caution, the 68% that claim you're not decision makers. In most of the county organizations that I see, and even Forest Service and BLM, those that don't think they're decision makers really do have a lot of influence on what decisions are made. People do listen to you. Hopefully they listen to your opinions. It's part of listening to a good team. That's where good decisions are made. So I feel your decisions and your opinions are highly valuable to the whole gravel road process. This is an ideal road. It's up near the Swan on your way to going to Glacier National Park. And it's just a beautiful road that's been stabilized, it's been taken care of right, and a good application of mag chloride. I appreciate your attention. I'm going to turn the time over to Ken.
All right, so Ken, it's going to be coming over to you so you can take control of the webinar here.
Okay, thank you very much. And good afternoon or good morning, or it may be tomorrow, if indeed we have someone clear out beyond the dateline. No matter who's listening, I appreciate the participation. I understand we had near 600 registered at the time we began, and that's great. I won't make a lot of comment immediately on the matters that Steve brought up and invited my comment, but I will make some comment about each of them as I get into my slides. But first of all, I noticed in the first poll, 88% were other or decision makers, and I'm assuming well, we could have a number of designers, consulting firms perhaps, or perhaps academia connected today. So I will slant it a little bit that way as I get on into this. But again, I appreciate everyone's participation. Here's what I was asked to cover to go on from the things that Steve talked about right up to if we're going to stabilize or simply do dust control. I will talk primarily about stabilization. 2 reasons. That is what I do most in my career. Some dust control. What's the difference? The difference to me is one basic matter, and that is in stabilization we try to get the product into the layer up to 2 inches, sometimes 3. I'll show 2 examples of that. Dust control is sometimes just surface treatment. Stabilization lasts much longer in my experience. And of course, dust control is there. Dust control is simply the bonus at that point. So, as you can see on the screen, there are 3 primary things that I'm going to build my presentation around, and that is quality of surface gravel only with comments. Steve has already covered that, and I appreciate that. I have 1 comment now as I identify this quality of surface gravel. We're going to talk about the use of chlorides. That's what I'm going to feature today. Again, 2 reasons. The bulk of my experience is with chlorides in the Central Great Plains region of the U.S. And consequently, the second reason, when you use those, a chloride is not a binder. And I think that's understood by virtually everyone. And consequently, if the surface gravel does not have a good natural binding characteristic, then the chlorides cannot take over with their hygroscopic characteristics, pull moisture from the atmosphere, and keep them bound. So again, I appreciate Steve's emphasis on it. He's absolutely right. I've found too often in my experience, plain old surface gravel is considered just that. It's sort of an afterthought sometimes. I hate to see it that way. If we are producing aggregate for hot mixed asphalts or for concrete or for chip sealing, virtually always we use pretty tight controls. When we get down to, again, I'll just use the slang term, plain old surface gravel, too often control is lax, and we really pay for it. Then the second thing I will emphasize is road prep. I'll use some slides to do that and give you some directions specific to shaping prior to treatment. Steve has already talked about the overall geometry, but I want to talk about the shaping you need to do prior to a treatment. And there's some drainage correction there, critically important, specific to the crown on the roadway if it's not there. Coordination with suppliers, which leads right into the last point, the application of the product. In my experience, particularly in the past decade, at least in the U.S., that has become much less of a problem than it was early in my career. I'll comment a little bit about that at the end. One thing I'm going to show you are just 3 slides here. First this one, 2 more, 3 more, about projects in which I've either been involved or have observed and had contact with managers. The road you are seeing is a treated road In the Black Hills region of South Dakota, it's semi-arid. There was virtually no snow that winter. The slide was taken in late February. The road had been treated, stabilized, if you will, the previous May. It received blade maintenance only twice in that cycle. And when it's working, you can get this kind of performance. The gravel is good, the shape and the prep was done correctly, application was good. This is the result you can expect. This is a rural road. Let me take you to a city. Laramie, Wyoming, and I have their permission to use these slides, actually treating streets. I'm not saying this is real common, but in the central and western U.S., we're seeing it more and more, and to be honest, we're using this as a paving alternative in quite a few regions of the central U.S. right now. This is a street near, as you can see, soccer fields, heavily traveled. I don't know what overall volume is. I couldn't get a count, but you can see the vehicles both traveling and parked. But I'm going to take you to the next slide. This one is, again, a street. It's an alternative to pavement for two reasons, perhaps three, but the first two are almost always we do not have the upfront money to pave. Should it be paved? Ideally, yes. But the money isn't there. But the second reason, and you cannot see it, but they have very weak subgrade soils. And unless you are able to do significant subgrade and base improvement here, it is almost useless to pave. And we have found these stabilized surfaces to be much more forgiving. It almost goes without saying here as well, you have an outstanding high-quality surface aggregate in place. And when it treats like this, you can expect this performance. This particular street serves a lot of trucks, two of them parked right here in the photo. However, I will be open, I will be honest, painfully honest in this case. I've seen almost total failure. And that's what you're seeing here. It's another project I worked on quite a few years ago. Virtually total failure in 1 month. And really, they had significant distress inside of 2 weeks. It was treated the same way. What's wrong? They broke all of the rules. There is not good surface aggregate in place. And as Steve emphasized, what's really missing here is the fines portion of the mix, particularly that percentage passing the number 200 sieve. It's simply not there, and what fines they do have are non-plastic, no plasticity index here. What few fines are there are simply silt fines or crusher dust, and they have no cohesive characteristic whatsoever. And I'm going to make one more comment about that to back Steve up. He likes to see, in addition to sieve analysis, liquid limit and plastic limit tests, which give us our PI, or plasticity index. I know that in some regions, some states are going away from this, and generally their argument is it's too subjective. And I understand that, particularly if you have lab technicians who are not used to running tests on highly plastic material. It's not easy. And I'm not here to talk about the test today, but I'm here to talk about the value of it. When you go away from that, it's a little bit like playing roulette. If you really don't know if the fine material is cohesive or simply non-plastic, then it's very hard to predict performance with these stabilizers, particularly, again, with the chlorides. So let me go on. I'll talk about two things here at once. A little bit more on gravel quality. This is outstanding, high-quality surface gravel. As Steve emphasized, you don't see a lot of stone in this material. You see the fines visually that he's talking about. I'm still scared of visual, though. I'm just like Steve. I want to see the actual lab test data. But I will tell you, because I've seen the data on this road, it was constructed several years ago now, but it was outstanding. A plasticity index in this material bounced between 6 and 7. Gradation was right down the middle. It meets a South Dakota gravel surfacing spec, which also happens to be a recommended spec in the Federal Highway Gravels Manual. And that actually requires 100% of the material to pass the 3/4 inch or 75 millimeter sieve. 19 millimeter sieve. And I like this if you have high volume, you're going to treat, and you want to get as close as you can to pavement performance. Otherwise, I have no problem with the 100% passing 1 inch or 25 millimeter, which he defined also. Excellent work here. I will simply mention this. Is it absolutely essential? No, I'm going to take you to a job where we didn't have one, but this is one of the very best tools for final prep, as I put on the heading here, of a roadway. What I like is these replaceable bit type cutting edges. You'll hear them referred to in the field as sandbag stingers, usually the trade names or the brand names of them. But what we've really got here is a shallow, scarifying characteristic, and that's what I like to see for stabilization. Here's what you can build with those. You leave a nicely shaped roadway, and note what I put on the heading. I love to see this for stabilization. Minimum of 2 inches of loose aggregate is better. Depends a little bit on the application rate of product you're going to use. But this is nicely shaped. You see right in the middle of the slide, nicely crowned. In this case, it's 4% crown. Steve recommended between 1/2 and 3/4 of an inch drop on the cross slope. 3/4 would be 6%. I would caution you when you treat, and it's working well, these roads can take on something close to a pavement characteristic, and be careful with that. Don't you ever exceed 6%. On the other hand, if it falls much below 4, you get too much risk of potholing, and then you have trouble with a stabilized surface, because I've seen the potholes, but the surface around it will remain so tightly bound you just can't hardly scratch it, and becomes difficult to maintain. This is just beautiful prep prior to treatment. I don't have the slides for sake of time, but they lightly watered this or pre-wet, and then they treated. This project was outstanding. I'll take you to a different one and show you a quick sequence where, in this case, we had gravel in place. The previous one had a fresh lift, 2 1/2 inches of virgin gravel brought in. This one was simply gravel in place. We had to loosen it. And I want to show you something here. The road lacked crown. And you can see where I was asking the operator to put some crown back in it. He's cutting here, if you can see my cursor, simply spreading here. Same way as he came back up the other side. We've got a nice shine. He's cutting here, but laying loose material up here in addition to the windrow. What happens if you put this back out? You're going to have much more loose material here, right here and under the windrow, than you will out here, and you won't have a uniform layer to treat. So he made yet more passes. Now you begin to see the shine all the way up to the windrow, and that's what we want to see. He returns back up the other side. Now you begin to see the cut or the shine all the way up. Now we have uniformly shaped the platform on which we're going to work. Now you can split that windrow, put it back down, and it's ready to treat. You've got a uniform layer to treat. In my experience, these projects seldom have much control. We don't go into them with a set of plans and specs. We don't even have a basic set of controls sometimes, which is kind of frustrating. So someone had better be out there at the field level managing this and doing a good job, or your risk of failure begins on day one. Again, this is a nice sequence of preparing gravel in place. Now he splits the windrow. The road is very narrow. He splits it, comes back up the other side, and I'm like Steve. I just cannot express enough my appreciation and respect for skilled operators. Excuse me, I will simply back up. I apologize. I didn't have the final slide in here, but you know what's behind him. He is perfectly cutting the road center right here. Other half of the material is placed over here, and then we prepare to treat. The key again is the gravel. So when I go to the next slide, I would like you to look at the poll. I'll read it with a little emphasis here. You see the question, do you have a county road? And you may be working with other entities, but I might just modify that. Do you have a local road surface aggregate specification to work with? You've got 4 choices. No, we don't have one. Or B, I'm aware of one. We're not currently using it. C, I'm aware of one. I don't believe we're using it. Or excuse me, I believe we are using it. Or D, we have one and we enforce it. I'll repeat. No, we don't have a spec. B, I'm aware of one, but we're not currently using it. C, a little more confidence. I am aware of one, and I believe, or I think we're using it. And then finally, we have one, and we enforce it. Answer those, please.
All right, good. Well, we're going to wait here for a couple seconds just to get the last couple votes in, because I can see they're rolling in as we speak. And I'll go ahead and close the poll for us and share the results. And it looks like we have a pretty big variety today. We've got 36% come in that say, I'm aware of one and I believe that we're using it. We have 31% answered, nope, we don't have one. 22% say that we have one and we enforce it. And our last 11% said that I'm aware of one, but we're not currently using it.
Okay. Thank you, Beth. I'm not surprised by this. Nearly 1/3 simply say no. Part of the problem there is too many of our states do not have a surface aggregate spec. In my case, my home state in South Dakota, we have one. I really appreciate that because it does give a standard with a pretty good authority behind it for which we can set up a spec, and contractors have to meet it. Otherwise, you do have to sort of stick your neck out. I will remind you, as Steve mentioned, there is a recommended spec, or at least a sample spec in the Federal Highway Gravel Roads Manual if you have nothing and you would like to begin. Okay, I'm going to go on. Oh, I'm sorry, here was final shape. I just had those juggled. Very nice job. Here's where you must make a decision, two decisions actually that I'll comment about. But the first one is, should we pre-wet? You cannot treat dry gravel with chlorides. That would be true with some of the other stabilizers as well, but particularly the chlorides. They will chase moisture down. This is right on the edge where you have to make a decision, should we or shouldn't we? You can see the shadows are long. It was a clear day up in northern Minnesota. Days are about 18 hours long, and we had a breeze, so we did go ahead and pre-wet. That's a call that someone has to make. If it gets any drier than this, just visually, you'd better do a little pre-wetting. Should you do this or not? Well, again, if it's cloudy and chilly, if I back up once, this will probably work. It has a damp appearance. That's okay, but when it's sunny, the day is going to be long. The sun's rising. It's getting warmer. We pre-wet. That's what we needed to do this in this case. Now, the next step, the application of the chloride, and I will make a comment without a slide, but you can see what we had done. We had pre-rolled one pass and get off of there. Only one pass. You be very careful with rolling. On the previous project where I only showed you the 3-slide sequence, we did no pre-rolling. We had a nice 1 to 2 inch loose layer. That was pre-wet and treated. Here we had to loosen more material. We did one light pass with rolling. Now, the treatment with chloride, we needed to get 1/2 gallon per square yard into a 2.5 inch layer in this case. And it's very hard to get that in one application. You usually can't, so we treated with a 1/4 gallon. You let that absorb, and I'm going to bring the cursor up. The other side may look the same to you, but we had treated both initially, and the other side has already absorbed 1/4 gallon. After about 40 minutes, we then did the second shot, and I'll make a point here. You watch this. If you feel you must do some rolling, watch this until you get good absorption. Do not ever put any compaction. No rolling when you have any shiny wet appearance. When you have gotten 100% absorption and you feel you must do some rolling, I'm okay with that, but don't roll too soon, as are already defined, sometimes not at all. It's a judgment call out there, and I'll make one more comment. I don't have text on there, but just remember this. roll the outer edge first because the public doesn't drive there. Then if you feel you must roll the traveled way, my best advice, one coverage of rolling is generally all you need, and get off there, and I'll explain why. Over-rolling will tend to pump that product back up, either very near or right to the surface, and that's what we don't want. We want penetration and absorption if you're truly going to stabilize. Here's the project about 1 hour after the final application and one coverage of rolling. This is not ideal, the barred tires of an ag tractor, but it is what it is. That's all they had. It's a township. They don't have a lot of resources. Sometimes they want to do some more rolling to try to take this out. My advice, don't do it. The traffic will. This road performed beautifully for the entire season. Not so much comment about this because, as I explained at the beginning, equipment has improved dramatically, at least in the area of the country where I work the most, which is the Central Great Plains of the U.S. Most of the time today, the delivery tanker and the applicator is one and the same, and that's what you're seeing here. We have an excellent vendor here. They show up with the transport. It has its own spray bar. It is pressurized, and if you look at the upper right, this applies through nozzles, much like an oil distributor if you're familiar with seal coating. And also this one is just that accurate. In the cab, it has an onboard computerized application system, and they can dial in the rate, and it will hydrostatically then work with the speed of the truck through a hydraulic pump, and it will either increase or diminish the application here to match the ground speed of the truck. I really, really like these units. Early in my career, we had too many that were simply tanks mounted on trucks, sometimes with nothing more than sewer pipe at the back as a spray bar with holes drilled in it. One gate valve, letting the product down through the bar, and too often what happened, we would tend to flood the middle, only dribble on the outside, and we did not get uniform application. These are outstanding if you're applying your own, and I do deal with some departments who do large-scale stabilization. They actually own their own rigs. If you're looking at that, I would say, number one, don't do it unless you can get all the way up to the level where you would have something. It wouldn't have to be a big tractor-trailer rig. It could be smaller, but get a pressurized application system. If you have a vendor who doesn't have one of these, talk about it. They're not super expensive, and I will just say the quality of our projects goes up dramatically when the final phase here, the application, is done this way. When you do it right, stabilization and, of course, the dust control that results from it is really effective. I want you to note right here, upper center of the slide, it's actually a county line, and that's sort of immaterial, except this county treats, this county does not. It's the same material. They're hauling material from the same source when they re-gravel these roads. It's interesting, this county does not treat for dust control. That's not even on their radar screen. They treat to reduce gravel loss and to reduce maintenance frequency with the motor grader. And when the gravel loss and the maintenance frequency of a motor grader either equals or exceeds the cost of treatment, they treat and they stabilize. Again, in this case, it's a liquid magnesium chloride. Here's a log truck coming off the untreated section onto the treated. It almost looks like the truck is stopping. Indeed, he's not. He's moving, as log trucks do, about as hard as they can go and stay upright. It's just simply the matter of a treated surface. So, of course, dust control is the bonus. I'm going to take you to another project that's been extremely interesting to us. I haven't watched this for a long duration. By the way, the previous road has been treated continuously for 18 years. This is a newer project, and again, you can read, originally constructed a little less than 2 years ago. I observed it last year after 1 year of performance. I will tell you this is actually an alternative to paving, and I'll show you why here in a moment. But here's how it was done. It goes without saying this is very high-quality gravel. I'm going to emphasize that again. I'm also going to just ask you to look closely at that surface. Are there any sign of potholes or any distress anywhere? No. Consequently, the value of prep and shaping, which Steve talked about, was also done very well. Here's what they did then. You can read the text across the middle of the screen. 1/2 gallon. There's the trade name, but this again is liquid magnesium chloride, if you're not familiar with it, was applied and incorporated in each square yard of surface at a depth of approximately 3 inches. I wasn't there. This is the data that was given to me. That treatment is a little lean for that depth in my experience. However, they had such high quality gravel in this case, it worked extremely well. It even worked on a significant crest vertical or a hill. They had no corrugation here with a 6% grade. That's the value, and again, sort of a bonus to the stabilization. Look at the truck traffic. This is done with a rather sophisticated counter. We not only got total vehicle volume, but we got a breakdown by type. This was a 3-day average count, and this is not during harvest or anything like that. The traffic here is relatively constant. 635, should it be paved? Well, yes, it should. They simply cannot afford the upfront price of paving, but also look at the percentage of trucks. This is a 3-day average, 103 daily. Here's the real bonus, if you will. This may be hard to believe, my friends, but I know the manager. I've been on this road 4 times in the last year, and we've gathered a lot of data. Absolutely no blade maintenance done in the year between initial treatment and then retreat. Now, if you don't, of course, here's what you have. I don't have to tell anyone about this. All of these 2 scenes, I shouldn't say all, simply 2 roads are far apart, different parts of the country. Both, frankly, should be paved, and they know that. They simply can't afford it. You really ought to take a look at stabilization in this case, because the loss of fines plus the loss of aggregate off the surface plus the frequent blade maintenance required here very likely is equal to or even greater than the cost of a stabilization treatment. You have to make that call. Here's a presentation summary then on behalf of both Steve and me. Gravel roads do perform very well if, and here's what he taught you: correct shape, good drainage. If it's not there, you have to construct or establish it, then thereafter you maintain it. And then, particularly if you're going to stabilize, you'd better have good surface gravel specified, handle it properly, and place it properly. And then stabilization, which I covered. It's very cost effective, and I want to emphasize that. If indeed your maintenance costs generally simply use of the motor grader and then your gravel loss, although that can include drainage if you're continually plugging culverts and so forth. Again, if your total maintenance and gravel loss exceeds the cost of stabilizing, then do it. Good surface gravel suitable for stabilization has to be in place, though, for this to work. And then good prep of it, and then the dust control, of course, is also there. It's a great bonus after stabilization. With that, I'm going to advance to the last slide on behalf of those sponsoring here, but I'll simply ask the question: would you be interested in talking to someone about DustGard, which is the trade name of our sponsor here today? And again, simply yes or no. Would you be interested in talking to someone about the product of the process? Again, simply yes or no. And as you're voting, I will also turn this back. This completes my part, by the way. So thanks again to everyone on behalf of both Steve and me. I will turn it back to our moderator, Beth. Thank you.
All right. Well, good. Well, you can just leave it there. We'll just advance it. And just pulling in the last couple votes here, and we're going to get on to some housekeeping, which is up on your screen. So we can just, that looks good. So just a couple housekeeping items before we move on to our live Q&A. And we've got some great questions in the queue here, but certainly time for more of them. And let me just, I'll go ahead and take this back. So just be a second here. But in the meantime, we'll just finish some housekeeping items, then I'll pick that slide deck up. First, your feedback is important to us, so please take a minute to complete our short survey, which will pop up after the webinar. Second, prior to the webinar, we did email out a link to the PDF of the presentation. If you did not receive one, please contact our coordinator, which is Amber at amickeldowney@forester.net. Also, we are recording this, and the webcast version of the webinar will be available for your viewing and for download at foresteruniversity.net. If you missed any part of the webinar or would like to view it again, you can do so via the link which we'll email out tomorrow. And we encourage you to share this webinar with others, so you'll be able to go ahead and send that on to other people as well. They can watch the webinar as well. We will also be emailing certificates to those of you who stayed the length of the program. If you do not receive a certificate, please contact our coordinator, Amber, at amickeldowney@forester.net. And with that, I'm going to go ahead, get this in slideshow for you, and we're going to put up the contact information for our speakers today, so that you have that. You should have it in your PDF as well as information for our next couple webinars, including So You Want to Set Up a Stormwater Utility, presented by Andy Reese on Thursday, April 18th, our Continuing Sediment and Erosion Control Masterclass series, which kicks off on April 24th and runs to May 31st. That'll be presented by best-selling author Gerald Fifield and Tina Evans. And finally, Clean Streets Mean Clean Streams, presented by Roger Sutherland on Thursday, May 23rd. And with that, we're going to open it up for questions. I'm going to jump us all the way back to the beginning, where we got a question here from, let's see, we've got a question here from Robert. And Robert asks, please address or comment on long, curvy steeps, 10%, driveways, etc.
Beth, would you like
Steve,
me to
you
comment on
go
Robert's?
ahead? Yeah, would you go ahead, Steve? I deal much more with straighter roads in the Great Plains. You may be able to do better on that one than me. Thanks.
No, please follow up if you have any other comments. But I will say, if you're in a steep, hilly, or curvy area, you've got the water moving on those roads, and it is important to have a cross slope to get it off, rather than having the water form a rut down the center of your road. As far as hills and curves, you'll notice that motor grader operators tend to grade material off the top of a hill. When they crest the hill, that moldboard will be sitting lower than the front and the back and the tandems. And so you'll tend to scrape material off the high points and fill them into the low spots. And so it particularly requires a high degree of skill by the motor grader operator to have a consistent roadway. Visibility is always a problem. If the county has the resources, we recommend that some of those curves be taken out, both the horizontal and vertical curves, so that you have safe visibility. And you can refer to your AASHTO Low Volume Roads Manual for that criteria. As far as driveways, anytime you get hot on the idea of cutting a crown on a road, and if you go out and cut that 4%, without having sufficient material, you're going to leave hanging driveways. Two responses to that. First of all, add the material and don't leave the hanging driveways. Second, if you do, the driveways are supposed to meet the road, not the reverse of that. And so the public will have to readjust their driveway to meet what the road is. I know that comment is not accepted well by the public, and we've cut crowns in roads and had along a certain roadway as many as 20 complaints by leaving hanging driveways. So be careful with that. You don't overnight cut that 6% crown in a road. It's something that happens slowly, and through the use of adding materials you can get the desired and established crown. Robert, I hope I answered your question.
All right, good. Well, good question there, Robert. Another one probably for you, Steve, because it came up early in the presentation. And this one comes in from Adam, who asks, what about organics pulled from the shoulder?
By saying organics, I assume you mean clay, and that is the difference between a silt and a clay. And when you get that pulled from the shoulder, again, relying on the skill of the motor grader operator to properly blend that material in with good surface gravel. In some cases, you can add a little bit of a clean gravel and blend it properly with some of the material taken off the roadside. It can form a pretty good gravel. Again, it's nice to take sieves along to see what you have and what you're mixing it with. But that material that you retrieve can help form good material in a good roadway. If you're in a county like I live in and don't have endless resources, nearly 1,000 miles of roads and a budget of around $2 million, we have counties in our state that with over 1,000 miles of road, they have around $1 million. And so they have to rely on retrieving these materials and blending it with the gravel on the road to get whatever they can come up with.
Could I add to that, Steve?
Mm-hmm.
I agree with you. And just to expand on that a little bit, I deal with that a lot, where we get higher rainfall in part of the central Great Plains and then the eastern U.S. And with organics, and you may be talking about the sod, or sometimes grass on the surface that you're going to pull up with. Steve showed a couple of those roads where in order to get rid of that high shoulder berm, you would have to do a pretty aggressive recovery of material. And in my experience, 90% of the time, that is reusable on the roadway. It may look pretty bad when you pull it up. And there are a couple of tools, discs are helpful for that. There are discs on the market simply called shouldering discs, or you can work it out on the roadway with nothing but an old ag disc if that's all you have. Also, if you do a lot of this, there are commercial pulverizers that will just literally shred a gravel windrow in about 2 passes. I don't think they're cost effective if you're maintaining a small system, and you wouldn't do much of this annually. But if you have an extensive road system and would do quite a bit of this annually, they can pay for themselves pretty quickly. That's all I have to add, Steve.
All right, good. Well, good question. Question in from Matt, and Matt asks, do you have resources and or recommendations of best management practices for extracting alluvial gravels and material from rivers?
Yeah, go ahead if you want that one.
Okay, my direct answer to the question is no. I do not have a manual or a resource on a best practice for that. I will tell you, again, 90+% of the time when you're pulling river gravels out, I assume with the drag line, or even in Nebraska, I've seen that done with pumps, invariably you're going to have a clean material because in part you washed it simply by pulling it out of the water. Here's what we've done with some of those when we're trying to get the really high-end results that I showed stabilizing. We will add a natural clay. And back to what Steve counsels, you have to know what you're starting with. Sieve analysis, it's probably useless to run liquid limit, plastic limit. You won't have PI, but you have to know what your overall gradation is. And then, I've actually had really good results with adding a natural clay. As much as, in one case, 9%, but we came out with a very good road. And Steve, I'll turn it over to you if you have better advice.
No, I just really like Ken's comments in a prior class. I heard a similar questions asked if they liked pit run or river run gravel or crushed rock, which is better, and Ken just stated that rock marbles were for children to play with. They move around and break up a stable surface, and fractured rock is really what you need. So I assume if you're pulling out rounded rock from the river that there is a crusher involved, at least I hope. And the other thing is, if you're going to be in a live stream, make sure and get your 404 permits and whatever state permits you need, because we're not allowed to do that in our state. There's probably better gravel sources out there, but if that's what you're confined to do, then go ahead and make the best use of it you can.
All right, good. Question in from Jennifer, and Jennifer asks, let's see, she asked it at about halfway mark at about 11:30, and she says the question is that with 6-inch minus stone size, shouldn't your thickness be 9 inches and not 8 inches so you can get compaction?
Beth, would you read that question again?
Sure.
Think about it.
She asks, when you have 6-inch minus stone size, shouldn't the thickness be 9 inches rather than 8 inches so that you can get compaction?
Boy, when we do a sieve test, like Ken emphasizes, that 6 inches is in its smallest dimension. So it might be a longer rock, an 8 or a 9 inch that's coming through there. I'll always be an advocate of fractured rock, even in the base. But when I mentioned that it's okay to have more rounded down there, it's hopeful there's less movement of rock down in the base. So a rounded rock, will just provide the free drainage and the support. Again, I always want a fractured rock, but if 6-inch rounded rock is what you have, it's okay down in the base. If you want to go deeper, I guess that's okay. The thought is larger rock. The thought is it's freer draining. Ken, please help on your experience with that.
Okay, I'll just add a little, Steve. I understand what she's saying, or I think I do. Back in my earlier work in construction, we used to have an old rule: don't place any lifts thinner than twice the thickness or the dimension of the largest stone. However, I have seen layers placed many, many times in my career that break that rule. And of course, what that really means, if you're going to have 6-inch top-size stone, then you would need to place a 12-inch lift. I'm not saying we've broken that rule many times, but I was actually taught that back in my interstate construction days. But I want to add one thing. When you're placing that very coarse material, the example that you used, Steve, or what she's asking, the motor grader operators need to put that material down, or in other words, lay it quickly without multiple passes, or what's going to happen, they're going to be chasing a windrow of stone, and the fines get away. And the skill of an operator is critically important when you're placing something like that. Is that making sense to you, Steve?
Yeah, it is.
All right, good. Let's see, a question in from Don, and Don asks, doesn't 12 to 18% passing the 200 leave us more prone to frost?
Okay.
Not necessarily.
Not yet, right. In the surface material, again, it's acting a little bit like a pavement, and it actually helps to shed the water. Ken, the top percentage on your fines in the South Dakota spec was lower than 18, wasn't it?
Yes, which is in the federal manual.
Right.
The upper limit passing the 200, which would be true fines, is 15%.
Yeah. And there's some good reasons for that. We moved to 18 in Montana because simply a lot of crushers, when they're crushing, have that much fines in the material, and we didn't want to reject it here at 16 or 17%. It doesn't drain as well. If that material was down deep, you would get some wicking and some frost heave. But that is surface material. We're recommending that much.
Yes, 18 is high, but keep in mind too, Steve's working overall in a drier region even than I am. Now, I'll make 2 more comments about that. If indeed you have some kind of a subbase or a base layer that is drainable, which Steve was showing in that typical section, this layer is only the surface where we're emphasizing not only the adequate percentage of fines, but at least some plasticity in it. Really, it's a trade-off, my friends. You cannot stabilize well, particularly with the products that we're talking about, and they're the most widely used in this country, unless you have that. Because if you don't have a natural binding characteristic in the gravel, then a chloride cannot take over and keep it bound. However, I want to qualify this if you are in Maine or Michigan, you can drop that by 5% quite easily because you get so much more moisture than we do. Again, we have attendees from around the country and even overseas, I believe. I think, you know, for sake of time, we can't dwell on that too much, but that has an effect. Steve and I are both in either semi-arid or arid regions. By the way, we're sitting hundreds of miles apart today. That's why we're having to interact the way we are. That's my input, Steve.
All right, good. We had a comment back on one of our conversations before that came in from Eric, and Eric recommends going back to the discussion about the gravel. He says, you can see a discussion of BMPs for river gravel extraction from Dave Rosgen and other geomorphologists. So that, if you want to check that out, you might want to do that. Let's see, we have a lot of questions in here, so we're just going to stay on the line and work through these. The next one comes in from Miltiades, and the question is, any groundwater contamination issues with the application of chloride treatment?
I'll comment on that right off. We worked very close with our Division of Environmental Quality, and their big concern was sedimentation of live streams, lakes, and marshes. And they actually required in their BMPs that any road within 100 feet of a live stream, lake, or marsh, they want treated. We see in numerous studies migration of no more than 15 feet off of the roadway, and that is true with depth also. In fact, we've seen that mag chloride migrate back up to the surface to chase water. Ken, can you comment?
I don't have a lot to add, Steve. Once in my experience, we had an issue with contamination of a well, but unfortunately that did not come from treatment of the roadway. Hose had come off a delivery tanker being pumped into the applicator truck. It's the only time I've had to deal with anything like that. In South Dakota, we have had some raging controversy over, well, groundwater contamination. The term is a little different here. But I will tell you, when we got to the bottom of it, unfortunately, it was winter maintenance. In winter maintenance, where we're also using a lot of the same or similar products and simply applying it on a frozen roadway or on a pavement, of course, that does run off. In my experience, I have not seen migration any worse than Steve mentioned, and I'll emphasize once more, you apply this into good gravel, and it retains it, and it holds it. You apply this to clean or non-binding gravel, and it will migrate. I'll turn it back to you, Steve.
That's good.
All right, good. Let's see. A question in from Richard. And Richard asked about halfway through, dependent on traffic volume, design, speed, runoff, volume, etc., have you seen good results with the use of water bars, broad-based dips, open-top culverts, or other water deflector devices?
I just got back from Arizona, and I'm used to seeing water bars in the mountains in our state. Forest Service uses them, and they use some little rubber bars that stand up and channel the water, and so that's what I was used to seeing. But in Arizona, they had quite a few of their roads with these water bars, and I asked about it, and they said for the monsoon season it gets pretty wet, and they have trouble because in many cases their road is the drainage path. It's lower than surrounding ground. So they had to channel the water off of the roadway and then daylight that channel to get it away. But, you know, they are very effective. They're very good for drainage, but it's an inconvenience for the driver unless you're in a mountainous area. And it's if you have a sufficient crown, which Ken has emphasized, they shouldn't be needed.
True. I have nothing to add, Steve.
Okay.
All right. A question here from Thomas, and Thomas asks, do you increase the slope in the curve?
Go ahead, Ken, please.
Okay. It depends on if you're trying to actually maintain a specific design speed, but I'm going to give you a caution on that. I don't like, and I assume we're talking about super elevation now in a curve, or the one-sided slope, if you will, in a curve. That's the correct shape. It needs to be there, but be careful with that. Steve showed in one of his illustrations there where you simply take the crown of the roadway, retain it on the inside of the curve, and then bring the outside up to match it. That would be no more than a 6% super elevation. And I'm good with that. And here's my experience. Don't you ever exceed 8, because I'm also in an area where we have quite a bit of snow in some winters, and when you get snowpack, even on an unpaved road, it becomes very slippery, and no one can stay on them. Don't ever go over 8, and I'm actually good with staying with 6% max in super elevation in a curve. And I'll turn it back to you again, Steve.
That was perfect. Just
okay.
All right, good. Well, we've got a ton of questions in here. Maybe you guys will ask a couple more, and you can let me know how long you want to stay on here. And if we don't get to any questions, not to worry. We'll get to you via email.
Beth, how about we just stay here until we get stumped, and then we quit and go home?
All right, that's good for me. All right, good.
Beth, I'm using a borrowed facility conference room. I'll stay for about another 10 minutes, and they will probably ask me to leave.
Okay, not a problem.
We'll get stumped before then.
All right, well, good. Well, let's see. A question here from Robert. Robert asks, please comment on recycled crushed concrete. We use -2 inches. Either -2 or just -2 inches.
You want me to comment?
Please. Yeah.
I've had quite a bit of experience with reclaimed concrete. I'll give you a quick summary of a lot of experience with it. We've had excellent success with reclaimed or recycled concrete in base repair, trying to correct frost boils and so forth with dig out. We will generally use a geotextile with it at that point as well. However, as a surface aggregate, I've had no end of trouble with it. Pardon my strong views, but if you're trying to do base improvement, I have found the material to work very well. As a surfacing, even as an interim surfacing, we've had a lot of trouble with it, and I don't like it. Over.
All right,
and
good.
Steve, if you disagree with me, jump in. But that's
no, I haven't
quick and dirty. That's my experience.
Yeah, I haven't had the experience you have with it, Ken.
All right, let's see. Question here from Adam. Adam asks, what is the slope % for the transition and super elevation when going around a curve on the roadway?
Ken answered that very well. I think that was complete.
All right, well, good. Well, Adam, maybe if you didn't catch it before, you can always listen on the recording and go back through that. Let's see. Murat asks, what is the liquid limit versus the plastic limit measurement?
The liquid limit is the % moisture over which that acts like a liquid. And that test is done with the brass dish. It's simply a hand crank. So you fill the dish with the material, and we test -40 material. And we fill that brass dish, cut it with a 1/2 inch groove, and we rotate the tapper. It taps it from a 1/2 inch until that gap, the 1/2 inch, closes at exactly 28 taps. So the test has to be done 4 or 5 times until you can draw a straight line and find the %. Then you take that sample and put it in the oven. And the amount of weight that was reduced is, when it dries out, is the % moisture. And just to give you an example, that may be 20% moisture when it closed at exactly 28 taps. So then that 20% moisture is your liquid limit, or the point at which it starts to act like a liquid, or quits acting like a liquid. And then the plastic limit is just with the 1/8 of an inch worm that you roll out, and when it crumbles at an 1/8 of an inch, that's the plastic limit. And the difference between the two, the 20 minus the 10, or depending on what your sample is, let's say it was a liquid limit of 15%, 15% minus, say, 11% for the plastic limit would be a 4% plasticity index. And in some cases, we'd be happy to have just 4%. Ken talked a little bit about how important those fines are and the silt. And Steve Monlux from the Forest Service talks quite a bit and has a spec that if your fines are high, but you don't have the plasticity, you may be okay. Or you have very little plasticity, like 4%. And if your fine percentage is low and you have a lot of plasticity, you're okay. But if your percentage of fines is low and you don't have the plasticity, he recommends adding bentonite to increase your plasticity. So there are additives that can be provided.
All right, good. Excellent question. Question in from Nazila, and Nazila asks, is there any relationship between the selected gravel sizes and the percent of the traffic in a road? Or do you think about the temperature of water that is spilled on the road?
I'll make a quick comment, Steve. In my work with local agencies, particularly if they're not going to treat, a very low volume road will be able to and I'm talking about simply total traffic volume. What's very, very, very low? Hey, I work with roads clear down at 25 vehicles per day or even less. You can get by with a marginal material. I believe in quality material everywhere, the best you can find. But again, if you've got an average daily traffic clear down there at 25 or less, a marginal material will perform reasonably well. You won't have to do a lot of blade maintenance. It won't treat, the part of it that I was assigned to talk about, but you're not going to treat a road most of the time with that low traffic anyway. However, in our dry regions, above 50, certainly above 100, then the size of material and its overall quality really begins to affect how the road will perform in the maintenance. We've already talked about that quality issue, but above 100 vehicles per day, we've even seen tremendous difference between a 3/4 top size control and a 1-inch top size control. But if you're east of the Mississippi, for example, in the U.S., where, that's not the perfect dividing line, but overall you receive a lot more moisture, then again, the 1-inch material will quite often perform reasonably well. And I've seen that up at 100 plus vehicles per day. So it's a little bit of a difficult question to answer because it's quite specific to the average annual moisture that you get. And I'll just stop there. What do you have to add, Steve?
Just that I believe South Dakota in the federal spec has a smaller top size because that allows you more fractured faces if you're running the typical crusher. And so they're going to interlock and stay in place better on the surface. I would say as your volume and your speed increases, people are less tolerant of the larger rocks, the 1-inch rock. And so then you would want to decrease your top size.
Yeah, I should have mentioned that. In my state and in much of the Central Great Plains, most of our materials are processed by crushing, but they are natural gravels. Up where Steve is, and in some regions where you have quarry gravels, then of course much different. You have 100% fracture. That really helps you. We don't have the benefit of that in most of our sources, so we are crushing natural gravels. That you're right. The smaller the top size, the more fracture we get. That's very helpful as well. But again, you can tie it to traffic. The higher the volume, the more trouble you're going to have with larger stone. That's all I have.
All right, great. Let's see, a question in from Jerome. Jerome asks, are chlorides or other constituents a concern from treated roadway runoff?
Steve, we probably covered that in part in the earlier question.
Yeah, I think
that
so.
became controversial in our Black Hills region, but I'll just repeat, when we got to the bottom of it, it was really our snow and ice control operations that were, and they were actually finding damage to conifers 10 and 12 feet above the ground, direct observable damage to the needles, and then we figured out that's where the snow plows were slinging the snow. So I'm tending to defend what we have presented today. Just once more, treat good gravel and do it well and get it confined in the material. I've seen very, very little trouble with runoff.
Okay, good. Let's see. Anthony wants to know, if stabilization is not anticipated, is there a need to modify the surface gravel gradation?
It depends on if you want a good road or not. I firmly believe that whether you're stabilizing or not, that good gravel pays off. You can't have a good, smooth, drivable surface without that. In some regions that I'm seeing around the country, there are good gravel surface material that doesn't meet those specs. In the south, there's a lot of caliche. It's a calcium carbonate. It's a lime material and kind of a natural stabilizer. And so, there are areas that are going to get some stabilized surface without meeting the exact specs that we talk about. I always feel it's better to have that sieve analysis and the good mix to back it up, no matter what kind of stabilizing you have. But yes, roads can be improved significantly without stabilizing. But if you're going to that level of effort to have material and improve it and really improve your roads, I think stabilizing is a huge benefit.
I have nothing to add.
All right. Well, good. Maybe one or two more questions, and then I apologize to the rest of you, but we'll get to you on email, or you can always contact our speakers today. You've got their emails right there. A question from Robert, who asks, how about centerline drainage on one-lane roads?
Well, I don't like it. I know what you mean by a one-lane road. That came up in a recent situation I was working with. It was literally 12 feet in width, and that was all. And of course, the motor grader is too wide; it can't even crown that. But in that case, and this was in a forested region in our Black Hills. I prefer either then, as they would say, in slope or out slope. I don't like center drainage. If you can avoid that in any way, there would be several options. And Steve, I think you deal with that more than I do, but I just really do not like it. Over?
Yeah, in the original presentation, which we had to shorten for this webinar, I have a 12-foot road with an extremely high pitch. The Forest Service in our area only gets to those roads but once every other or every third year. And they put, on a 12-foot road, they'll put 8 to 10 inches of fall from center line to edge line. Horse trailers don't like it. But again, the quicker you get that water off the roadway rather than in the center, the better your base and your surface is going to be.
All right, good. Let's see. Well, we've got a bunch of questions in here, but let's see. Ken, you need to get off the line here probably in a minute or so.
I am going to have to leave you in about 1 minute. I apologize, but I'm at their mercy here.
No worries. Well, we've been on for about 40 minutes of Q&A anyway. Just really good questions in from everybody in the audience. And I did just put a note in the chat box. Peter had suggested that you all might want to check out Steve Monlux's publication, Surface Aggregate. Let's see, Surface Aggregate. My screen just jumped there. Surface Aggregate Stabilization with Chloride Materials. It's a good source for costing alternatives, so you could check that out over there. For the rest of you, thanks for putting your questions in. We'll definitely get back to you, or you can contact our speakers. But before I close it up here, Steve and Ken, you guys have any final comments you want to make to the audience or leave us with today?
No, simply thank you. We appreciate your time.
Yep. I agree. Thank the audience, and thank you, Beth, for doing an outstanding job hosting that.
Well, great. Well, thank you both. It was a great webinar today, and like we said, you can catch the recording of this or pass it on to your friends. I will be sending out the link tomorrow. Thanks for the excellent questions. In the Q&A here, we just had a ton of those and really informative and added to our discussion today. And, of course, thanks to today's webinar sponsor, which is Gravel Roads Academy. Gravel Roads Academy, sponsored by the North American Salt Company, offers information and training on how to better maintain your gravel roads for superior stabilization, greater cost savings, and better air quality. The course curriculum includes road design, road maintenance, road stabilization, program efficiency, and field training. And of course, to learn more, you can visit them at gravelroadsacademy.com, which you'll find in your PDF deck as well. We hope to see you all at our next stormwater webinar, which is so you want to set up a stormwater utility. For those of you in our stormwater audience out there, they'll be presented by Andy Reese on Thursday, April 18th, exploring the top 10 ways that utilities fail to get off the ground successfully, and more importantly, how to avoid these. Also, we're pleased to announce the return of our best-selling Sediment and Erosion Control Masterclass series for our erosion control people out there, starting on April 24th and running through May 31st. During which best-selling author Jerry Fifield and Tina Evans will dive into advanced, comprehensive 6-part live and on-demand masterclass and workshop series, which will explore the ins and outs of effective sediment and erosion control plan, design and review. And this will be following his manual, Designing and Reviewing Effective Sediment and Erosion Control Plans, which is included in the package. This series is worth 9 PDH credits and 0.9 CEUs. But until then, thank you all for joining us today. Again, we'll be sending out the webinar recording to you, and we'll be answering the rest of our questions today via email. But have a great day.